Okay, class, this is the second part of sections 9.4 through 9.7, the metric measurements. It says the U.S. is one of the only countries in the world that does not use the metric system. However, on the books, you would think we do. In 1975, the Metric Conversion Act of 1975, Public Law 94-168, was passed by Congress. The Metric Act established the U.S. Metric Board to coordinate and plan the increasing use and voluntary conversion to the metric system. However, the Metric Act was devoid of any target date for metric conversion. In 1988, the Omnibus Trade and Competitiveness Act of 1988, Public Law 100-418, amended and strengthened the Metric Conversion Act of 1975, designating the metric system as the preferred measurement system and requiring each federal agency to be metric by the end of fiscal year 1992. In the previous lesson, we converted English measurements using dimensional analysis. However, with the metric system, we convert by moving the decimal in the direction that it occurs in the chart below because we are dealing with multiples of 10. We did an example of this in section 5.3, page 92. Okay, the metric prefixes. We have our base. Now, we've dealt with the bases before, like one of our bases is meters. Another base is grams. And then we have another base, which is liters. Okay, these are our bases, and then we will have like centimeters, centigrams, milliliters, and everything like that. But our base is these values here. Okay, now it says the base values of a metric unit is always denoted by a single letter, like M for meters, L for liters, and G for grams. All the other prefixes except deca include the first letter of the prefix and the base, i.e. cm. So we have centimeters, so that C represents the centi, this M represents milli, and this K represents kilo, etc. Note, deca includes DA. This is the only one that includes DA. So unlike the others that only have two letters, this will have three when you're dealing with deca. So DA and the base, i.e. DAG, stands for decagram. Now it says here, examples, convert each measurement as indicated. We have 46 meters to centimeters. Okay, now meters is our base. Now we want to go from our base to centi. So we look here, we move 2 places, right? We move 2 places to the right. So we'll move this decimal 2 places to the right. And we know that the decimal behind this 46 is at the end. So we'll move that 2 places to the right, and we will add zeros here. So our final answer here would be 4,600 centimeters. And that will be our final answer. Now we come here to problem number 2. We have 14 millimeters to centimeters. So we'll go to milli, and we'll go here to centi. So we need to move 1 place to the left. So what we would do is we would take this 14, put our decimal at the end, and we have to move 1 place to the left. So it will be 1.4 centimeters. And that will be the final answer here. Now we go here to number 3. We have 400 meters to kilometers. So we have our base here. Now to go from the base to kilometers, we have 1, 2, 3 places. So we need to move our decimal 3 places to the left. So we'll write 400, put our decimal here at the end, and we have to move it 3 places to the left. So that will give us 0. Now you could write 400, or you could just leave it at 0.4 kilometers. Okay, now for number 4, we have 6,400 millimeters to meters. So we will go from milli to the base. So we would have, you could go 1, 2, 3 places to the left. So we'll take this 6,400. We know a decimal is at the end, and we move it 3 places to the left. So our final answer here would be 6.4 meters. Okay, now this covers the first page. Now we go here to the second page. Now we're going to go from centigrams to decagram because this is a DA. Now what we need to do here is this here. We're going to rotate, but before we do this, grams and kilograms. We know our base is grams, and you can look at your formula sheet. Now you go to your base and you have to move 3 places to the left to get to kilo. So we will have 4.9, and we need to move 3 places to the left. 1, 2, 3. So our final answer, we'll put these zeros here, and we know our decimal will be here. So our final answer would be 0.0049 kilograms. Now we go here to number 7. We're going from liters to kiloliters. Basically the same operation here. It's the base to kilo. So that means we'll move to the left 3 places. So we have our 0.127, and we'll move 3 places to the left. So now we would have 0.000127 kiloliters. Now we go here to number 8. We have 1.9 liters to milliliters. So that means that we will go to the base to milli. So what we're going to do here, before we do anything else, we want to go from centigrams to decagrams. So we need to go from centi to deca. So we go up here. Centi to deca, we'll go 1, 2, 3 places to the left. So we scroll back down here. So we had to take this 4.26. We'll move 3 places to the left. 1, 2, 3. We'll put our zeros here, and we know our decimal goes here. So it'll be 0.00426 DAG. And that will be your answer for number 5. Now we want to go from liters to milliliters. Now this is the base to milliliters. We will have to go 3 places to the right. Now you can look at your chart. So we have 1.9. We'll go 3 places to the right. So we have 1900 and a decimal point at the end. So it'll be 1900 milliliters. And that will be your answer. 1900 milliliters. Now, we scroll down to the operations with units. It says perform the indicated operations. We have 4.8 liters minus 283 milliliters. Now, what would make this easy if both of these are in the same measurement? Now, we know what I would suggest we do is change milliliters to liters. Now, when you go to milli to the base, you move 3 places to the left. So we'll move this 1, 1. Well, it's not showing up, but 1, 2, 3. So we could write this over here to the side. We have 4.8 minus, it'll be 0.283. We can add our zeros here. And we know this would be a 10, this would be a 9, and this 8 will become 7. 10 minus 3 is 7, 9 minus 8 is 1, 7 minus 2 is 5, bring down your decimal, and 4 minus 0 is 4. So your answer here will be 4.517, and it'll be liters because we converted everything to liters. Now, we go over here, we could do the same thing here. We could change this milligrams to grams. So we'll put our decimal here, and you know we have to move it 3 places to the left. So we will have, so now we would take 2.1 plus 0.153. We know both are grams. We will add add 2 zeros here as placeholders. And now we add. 0 plus 3 is 3, 0 plus 5 is 5, 1 plus 1 is 2, bring down our decimal, and 2 plus 0 is 2. So our final answer would be 2.253 grams, and we are done. It says now we will return to dimensional analysis to convert between English and the metric units. So this is going back to the previous lesson. Now what you would have to do is this here. Because I don't have this readily available, I'm going to be scrolling down, so you need to have this sheet out as I go through this exercise. So you might want to press pause. Now we're going to scroll down and go to our problems here. Now it says convert each measurement as indicated using the chart on the previous page. Now I hope you all have that chart out. Now we want to go to 18 liters to quarts. So the first thing we need to do is this here. We need to find liters on your chart. Now if you're using the sheet that's above this, we need to go from liters to quarts. So what you would look under, capacity, and it would be the last value. The last value states, and I'll write this over to the side, is 1 quart is equal to 0.946 liters. Now this is supposed to be a 4. So it'd be 1 quart is equal to 0.946 liters. So what we would do is this here. We would take our 18 liters, put that over 1, and multiply it by the dimensional analysis. Now, we know that whenever we divide by values that are equal to each other, we're really making 1. Anything multiplied by 1 is itself. So we're trying to get rid of liters. So we will put the liters value in our denominator. And our numerator would be our quart value. So this is really being multiplied by 1. So these liters would simplify out, and we will have 18 times 1 quart will give you 18 quarts. And this will be all over 1 times 0.946 is 0.946. Now, I do not know why this line keeps coming over this 4, but it's 0.946. And now we would take a calculator. You could take this calculator and take 18 divided by 0.946. And that gives us this long decimal here, but we're going to round to 2 decimal places. So it'll be approximately 19.03. So we will put our approximation value, and it'll be 19.03 quarts. You know this is supposed to be a Q. So this is quarts. Okay, now that takes care of problem number 1. We go to number 2. We had 86 miles to kilometers. So now we look here on the conversion chart again, and you look under length. And I'm talking about the conversion chart that's right above this page on the previous page. So we have 1 mile is equal to, and I'll write that up here, 1 mile is equal to 1.6093 kilometers. And we will write this out. You add 86, and I'm going to abbreviate miles with MI over 1 times, we want to get rid of miles. It'll be 1 mile, and then in the numerator you add 1.6093 kilometers. Okay, now miles will simplify out with miles, and then you would just take 86 times 1.6093.